What I'm much more interested in when it comes to societal change is the very near term, the spread of widespread anticipation of these therapies. In other words, most people are going to understand and realize that these therapies are coming, probably in time for them, and so they're going to make very different choices about how to run their lives.
Good morning, everyone. I am really excited because today I'm joined by my good friend, David Granovsky of A Neighbor's Choice, and a very special guest who probably needs no introduction. But for those of you who may not know of him, we are joined today by Dr. Aubrey de Grey. Dr. Aubrey de Grey is a mathematician, a pioneering gerontologist, teacher, and author of several books, including The Mitochondrial Free Radical Theory of Aging, published in 1999, Ending Aging, The Rejuvenation Breakthroughs That Could Reverse Human Aging in Our Lifetime, published in 2007, and Advancing Conversations, Aubrey de Grey, Advocate for an Indefinite Human Lifespan, published in 2016. He has been seen and heard on 60 Minutes, The Colbert Report, and The Joe Rogan Experience, as well as the documentary The Immortalists, which came out in 2014, and where I first learned about his research and work. So without further ado, Dr. de Grey, how are you?
I'm very well, thank you. How are you?
I'm doing all right. So the first question I want to ask is, how did you get started with this with the in the field of gerontology and life extension?
Yeah, I had an unusual introduction to the field. I started out when I was an undergrad being a computer scientist, not a biologist at all. And I worked in research in artificial intelligence for several years. But during that time, I met and married a biologist. And she was a lot older than me. She was already a senior professor in California, and she was in England, where I lived, on sabbatical, in fact. And over the next couple of years, I accidentally learned a lot of biology just by asking her what she did today, every day.
Right.
But I also began gradually to realize that we were never talking about aging. And I started asking her about that. And the basic answer was that she wasn't interested in aging.
Right.
And in fact, biologists in general didn't seem to be interested in aging. And I was astonished at that. So eventually I realized that I had to switch fields. I had been reasonably successful in my computer science research, so I knew I had what it took to work on difficult problems. And I also knew that often when researchers switch fields, they achieve a lot of good stuff in their new field simply because they're not encumbered by the conventional wisdom. And so I thought I'll have a go at this, and here I am.
Wow. Wow, that's great. So you're saying that you had to get out of the field that basically supposed to focus on and aging and biology in
That's
order
right.
to
Yeah,
yeah.
so I got my PhD in biology after that. I actually got my PhD basically for that first book that you mentioned, the mitochondrial one. But I didn't have any formal training in biology. I got it all just by talking to my wife and other biologists, and also by reading a lot.
I in high school, I was interested in biology and things like that, but I never really saw any real application. It was all kind of
Hmm.
academic study, books and stuff like that.
Hmm.
But I wanna kind of get down to more earthly, a more earthly realm, and that's if you were gonna explain, anti-aging to someone, just a regular person, how would you explain that to
Yeah,
someone?
well, I hope I can do that now because I've certainly been asked to do it many times. Um, yeah, it's actually not nearly so hard as you might think.
Okay.
Because it all just starts from a very simple thing that we're all perfectly aware of, namely that the human body is a machine. It's a
Right.
physical, thing with moving parts, same as a car or an
Yeah.
aeroplane. And of course, it's a
Yeah.
really, really complicated machine. And of course, we don't have the blueprint the way we do for a car or whatever. But
Right.
still, it's a machine, and that is very useful to bear in mind because what it means is that the function of the body is determined by its structure and its composition. In other words, the only reason that an older body doesn't work so well as a younger body is because an older body has a different structure and composition. So really, all that we need to do in order to medically reverse aging and keep people youthful is to figure out what those differences are at the molecular and cellular level and repair them. Essentially, the differences can be called damage, same as rust is damage in a car. And it turns out that that's actually not very difficult to do, to describe the damage, because, of course, people have been studying aging for a long time, and even 20 years ago, people were pretty clear what the differences were, what types of molecule were accumulating, what types of cell were being depleted over time, things like that. And of course, we couldn't be sure that we knew everything, but we could be fairly confident because it had been nearly 20 years by the time I started thinking this way, since anyone had discovered anything new, and now it's been another 20. So, good news, really. We probably know everything we need to know. Now, of course, that's only the first step. The next thing you have to do is figure out how to actually repair the damage. That's really the big contribution I made 20 odd years ago now, was to essentially take all of the things we knew that changed over time in the body and classify them into a manageable number of categories. So I normally talk about just 7 categories. Some other people use different numbers, but basically I have 7 categories. And the reason that's useful is because for each category there is a kind of generic approach to repairing all the examples within that category. So if I give you an example, loss of cells dying and not being replaced by the division of other cells. Of course, in most parts of the body, that is what happens. Cells divide to replace cells that die. Fine. And so the number of cells doesn't change. But in some places, especially the brain and the heart, that doesn't happen. Cells die, not very often, but they do, and they're not replaced. So the number of cells goes down, and eventually you get problems. The one aspect of aging which is particularly driven by that one type of damage is Parkinson's disease, because there's a particular type of brain cell that we lose in large numbers. So, what's the solution? The solution is stem cell therapy. We put cells back into the body that know what to do, to divide and transform themselves into replacements for the cells that the body is not replacing on its own. And, of course, different parts of the body need different stem cell therapies. But that's kind of, that's in the details. All stem cell therapies have a great deal in common. So once you've got 1 or 2 of them working, it doesn't take very long to get the next one working. And so, yeah, that's why classifying this very large number of types of damage into a small number of categories is so useful.
Okay. Where would you get the stem cells to add to the body? I mean, is it coming from another person, or is this being created in the lab?
Great question. So that's been changing over time. So let me actually use the illustration of Parkinson's disease in a bit more detail, because the history of that is quite instructive here. So the very first time that anyone tried to do this kind of thing, we didn't know anything about how to manipulate stem cells in the laboratory. So a group in Sweden actually they tried to obtain the right kind of stem cell from the brains of aborted fetuses. It was really hit and miss, because of course aborted fetuses are small and the brains are really small, and you had to get a particular place, a very small part of the brain, where the particular type of cell was. It was very hit and miss. The result was that when they tried injecting these cells into the brains of people with Parkinson's, by and large, it didn't work. Didn't have any effect. But occasionally they got lucky. They got the right kind of stem cell, and so a few people got a response. And the response they got was spectacular. When it worked at all, it worked amazingly well. So people were literally, completely cured of Parkinsonian symptoms for more than a decade, just from one injection. But that was, as I say, very hit and miss. But now it's not like that, because now we know a great deal about how to manipulate stem cells in the laboratory. We can even take cells from the person who has Parkinson's, cells from the skin or whatever, and what's called de-differentiate them, turn them back into really primitive stem cells, and then turn those cells into the right kind of stem cell that we would want to inject. And that's been done now. There's a group in Japan that have got a good expertise in this, and they're actually conducting a clinical trial right now, and people are very optimistic. There are a few other clinical trials starting up in the US fairly soon, going the same kind of way. So yeah, that's how you do it.
Okay, great. I mean, that's interesting that you mentioned that. because I want to talk about this idea that, a lot of people probably uh, have like ethical problems and stuff like that with when it comes to, stem cell research and things. But you know, you mentioned something. I looked this up on Wikipedia, so I don't know if it's true or not. We don't know if we can trust Wikipedia, but I'm gonna go for it today. You mentioned this idea that people, the knowledge is there for this, but the funding is not there.
Well, actually, that's been changing. So
Okay.
first of all, of course, we don't have all the knowledge. That's what clinical trials are for. To they're experiments, just like laboratory experiments. But we
Right.
have we have a lot of the foundational knowledge, yes. So we're in a position in many cases where we can do clinical trials.
Right.
Um, Actually, funding is changing. So,
Okay.
until even a year ago, I would have absolutely said yes. The main thing slowing us down is lack of resources, and especially lack of resources to fund the really early stage work in laboratories that is necessary for proof of concept of these things. That work, because it's early stage, people understand that it might or might not work, and so investors and donors and so on, they're a bit hesitant to get involved if they want to make money in the end. Whereas
Right.
the later stage things, even though they're more expensive, it's actually easier to get money for them because people have seen that kind of the concept has been de-risked.
Right.
But now actually things are changing. Last year was an extraordinary year for early stage work in anti-aging research, especially because of the arrival of quite a few very wealthy people from the cryptocurrency world, from the blockchain world. Um, People who had, created their own cryptocurrencies that are now really high and so on. So we got in July at Sense Research Foundation literally an additional digit on our bank balance. We received $27 million, which was like 6 times our normal budget for the year. It was like extraordinary, and we got that almost all from crypto enthusiasts during
Wow.
something during something called a sacrifice phase in the process of creating a new currency. And we were not the only ones. Lots of other people got that kind of number, 8-digit numbers last year, both
Mhm.
in the for-profit and non-profit sectors. So I would say that now, actually, the main bottleneck is not money at the moment. It is personnel. We don't have enough talent in the field. People who are really good scientists know how to do these experiments, and so we're hiring, we're recruiting as much as we can, trying to speed things up with the benefit of this new funding, but we are struggling to find the best people.
Right. If you don't have scientists and things like that, who can engage in this kind of work, what's another avenue that we can take? Because, a lot of people probably, are not educated in this field and really don't
Yeah,
have.
well, of course, the simple answer is I go out and do a lot of interviews like this. Because
Right.
at the end of the day, there are enough scientists out there. There are people who have the right skills. It's just
Yeah.
that they don't necessarily know that they can apply these skills or that necessarily feel motivated to applying these skills to the longevity research area. And
Right.
so I go out there and get the word out and get people to understand that here is an area where they can be really fulfilled and make a big difference and work with fantastic other scientists. That's the way to do it.
Right. So with that, I want to ask you something because I think that with anti-aging, there's also a kind of a, like you were getting the word out, speaking, doing interviews. There's a cultural sort of component to this where various groups might have some skepticism because of their background, their culture, and they might say, see it as sort of something out of the norm or
Mhm.
something like that, right?
Yeah, and of course that it takes time to break that kind of thing down. It's a bit like the
Right.
stem cell thing we were talking about before. So I mean, of course, you mentioned how there used to be ethical concerns about stem cells, but there really aren't anymore. And the reason there aren't is because of this method that was developed 15 or so years ago to take normal cells from an adult and convert them back into stem cells so that we don't have to destroy embryos anymore in order to make them. So now, there's no ethical issues around stem cells, really, not anymore. Whereas, and it's the same with aging. Historically, aging was considered to be, natural and universal and inevitable and kind of off limits to medicine almost.
Right.
But that's not true anymore. People like myself have been out there long enough now that, the zeitgeist is pretty much familiar with the idea that aging is a medical problem that has the potential to be addressed with medicine that's being developed right now. Of course, it's taken a long time because there aren't very many people like me out there doing that, but there
Right.
are a few, and we're pretty much there now. That's really why we got this influx of money last year, and it's not just from the crypto people. You probably know that Jeff Bezos put a huge amount of money into aging research
Okay.
last year. So,
Mhm.
and there's lots of other people like that doing the same thing. So I think that battle is more or less won.
Okay, great. Now I've got my friend on here, David Gornoski. He's with us now. David, can you hear me?
Yeah, how you doing?
I'm good, brother. We got
Hello,
Aubrey
David.
de Grey on, man.
That's great. It's great talking to you again. It's been a few years since I had you on the radio show, so it's great to catch up with your work and what you've been doing since.
Totally.
I remember one thing we were looking at was some of the work Dr. Michael Lasanti was doing at Salford University in regards to some of the antibiotic research he
Hello.
was looking at.
Yeah, David. So yes, I remember that. Yes, I haven't been in touch with Michael for a little while, but he was doing fascinating work for sure.
So what do you think is when are we going to start seeing people live into 200s and 300-year old? Or how close are we to that?
Well, of course, I keep updating those predictions in the light of progress, and I'm pleased to say that progress is definitely being made. I think we are now within only 15 years of having at least a 50-50 chance of reaching this thing that I've called longevity escape velocity. So, of course, we definitely won't have any actual 200-year-old people for at least another 100 years because it takes that long to get that old. But I think that we have a good chance of having having sufficiently good, sufficiently comprehensive rejuvenation medicines 15 years from now that people who are in reasonably good health at that time will have a good chance of never suffering from the health problems of late life and thus definitely have a very good chance of living to extreme ages.
Right. Do you think that this COVID thing has accelerated aging though for a lot of people? It seems like it was like a cocktail of aging effects that it's done to the population. People
Yeah.
have chronic. It was like because it was attacking the ACE2 host receptor, which is so associated with senescence. It seems like it was like a pickpocketing all kinds of. It was like taking advantage of your aging weak spots in your body. So some people have eye issues because of COVID long term. Some people have um, issues with their back pain. Some people have heart problems. Do you think
Yeah.
there's something accelerating about aging with this disease?
Well, it could be, yes. I mean, essentially, any disease that has chronic after effects has the potential to accelerate all aspects of aging. People say the same things about HIV, of course. That even though HIV is very well controlled by antiretrovirals these days, those drugs nevertheless do have significant effects, and people see acceleration of various aspects of aging in HIV sufferers. So it's probably going to be the same kind of thing, but the magnitude of that effect is something that we absolutely can't estimate at this point even. Certainly what we can say is that the people who have the most severe suffering from COVID are people who are already in a bad way for other reasons. And so perhaps those people would not have much chance of sticking around long enough to benefit from longevity escape velocity anyway. Nevertheless, certainly the sooner we can alleviate and address these long-term side effects of COVID, the better. I completely agree.
I want to ask about, societal changes. So what do you think is going to, what sort of societal changes would you expect to see with this technology?
Right. So, I mean, of course, one's got to be very, very careful in making any predictions about the distant future. Like,
Hmm.
let's suppose that we assume that 50 years from now, these therapies are just going to be routine, and and it's basically going to be almost nobody who's actually biologically old, even though, of course, there will be plenty of people who are chronologically old.
Hmm.
Um, then, we can, imagine a lot of different changes, but of course, we have to remember all the things that we can't imagine. The fact that, other technologies are seeing progress as well, and we just don't know what's going to happen. I mean, if you think about the extent to which we could have imagined 50 years ago the nature of the world today, it's a joke, really. So I'm not
Right.
really fond of trying to predict that kind of thing. What I'm much more interested in when it comes to societal change is the very near term, like the next 5 years. And the reason I'm interested in that, even though that's much sooner than the time frame I just gave you for the arrival of these therapies, is because I do think that what's going to happen in the next 5 years or so is the spread of widespread anticipation of these therapies. In other words, most people are going to understand and realize that these therapies are coming, probably in time for them, and so they're going to make very different choices about how to run their lives on the basis of having an expectation that they're probably going to live a lot longer than they otherwise thought, than they previously thought they were going to live. That's going to change, the really big ticket items that drive the global economy, things like, pensions and life insurance and health insurance and, inheritance arrangements. It's going to be extremely turbulent. And I spend a lot of my time these days trying to get people in positions of power and influence to actually understand that now and plan ahead so as to be able to minimize that turbulence as and when we get this really sharp, sudden realization on the part of the wider world that this is coming, which is only going to be a few years away from now, I think.
Right.
And is there a key drug or platform, or what is the leading contestant for dramatic reversal of aging? Is it a nanobot? Is it what is it? A cocktail of drugs?
Definitely a cocktail of therapies, yes. Not just drugs. It will certainly include gene therapies and stem cell therapies, variety of different things. And the reason it's definitely going to be a cocktail is because of the nature of aging. Aging consists of the accumulation of a very large number of different types of damage in the body. I was just saying earlier that these types of damage can be classified into a relatively manageable number of categories, but that doesn't mean that you necessarily can get away with a small number, let alone one, of therapies. So we're going to be doing a lot of different things to the same people at the same time, which is a problem in itself for the medical profession, because the medical profession tries to keep things simple, and they're not really keen on combination therapies, but they're going to have to bite that bullet in this case.
Back to the question of inheritance. I mean, we're talking about royals and the monarchy. That's going to have to be adjusted too, right? Because
well, I mean, honestly, I have no idea. I mean,
yeah.
The first of all, we're still going to have people dying. It's just they're not going to be dying of aging. They're going to be dying of being hit by trucks and stuff.
Right. Chaos.
Yeah. But also, I mean, we've had plenty of developments in history that have dealt with this kind of thing already. The introduction of term limits, for example, for the US president. That happened some time ago now, and it wasn't very difficult to make it happen. You can do the same thing for all manner of different kind of things. Right.
Just as like a transition into something else. Right. My last question, I'm sure David has others. How can people like us, like me, promote this and try to, get the word out about this? Because, I think this is very important for just regular people. And, I mean, that's not to say that, other people are not regular, but you know what I mean.
So, I mean, the first answer to your question is you're doing it right now. You're interviewing me. That's a very good start. The more people hear this message from the mouths of the people who are leading the charge, the more they will understand the kind of scale of what can be done in principle in the relatively near future. And they will be more motivated to make it happen that much sooner. Of course, you're completely right that the wider world needs to understand this as soon as possible, largely because that's what will motivate public spending on this, which will definitely speed it up a good deal. That's already happening to an extent. People are lobbying Congress and so on to get this to happen faster, but the ultimate driver of that will be the general public, because ultimately, politicians really only have one motivation in life, which is to get re-elected, and and there's only so much they're going to do, unless and until they think that there are votes in a particular way forward.
Wow.
So getting the word out is vital. Of course, everyone's different. You know, people like you can interview people like me,
Yeah.
but wealthy people can give money or invest money to move things further along. Scientists, can choose the most impactful area of biology to work in. Um, but everyone can do advocacy. Everyone can talk to their friends and their families and their colleagues and generally get
Yeah.
people to understand that aging is a tractable medical problem, not just some
Yeah.
natural, inevitable phenomenon that we have to live with.
That's exactly right. Because I know in my personal life, I may not understand all the scientific, research and everything. I try to advocate on a cultural level, with especially with African Americans, and my friends and family, because I believe in this, and I think it's something that everyone should, even if they don't understand the fundamentals, can get behind, just on a conversational level.
Yes, absolutely. The more people talk about it, the more people will learn.
What did you think of that story with the frog limb regeneration? Did you guys talk about that?
We haven't talked about it, no, and indeed I haven't read the paper yet. I only was made aware of the story yesterday, so I'll be reading that today probably, and I don't have anything intelligent to say about it until I have.
Yeah, it has something to do with anti-aging, though. I'd imagine. There's got to be something there, right? In
Possibly,
principle.
yes. Yes, possibly. Regeneration is something that certain other species, like frogs, can do much better than we can, and the possibility of somehow introducing or reawakening that regenerative capacity in humans is by no means out of the question. A lot of people have been working on that for a long, long time, and making incremental progress in understanding what's really going on there in terms of genetic control. Of course, the thing that we have to worry about is how to stimulate all of this cell division that's required for regeneration without stimulating cancer.
Right.
And that's something that really, is at the center of a lot of medical research in aging. Essentially, you can think of aging as kind of you know, there's cancer and there's everything else. Everything else is, less regenerative than it could be because of the need to kind of find a happy medium between being too regenerative and thereby promoting cancer.
Yeah, we certainly don't want to have little regenerated, tiny little limbs that are filled with tumors. That's not going to help anybody.
That's right.
Yeah.
Oh, I just wanted to kind of talk about some of the big picture things that you're seeing in this space. Are you seeing a level of industry support and FDA support for this space that you haven't seen before in previous years? Because you've been
Oh
talking about
yes,
this for some time.
that's right. Yes, it's changed completely. Really, the arrival of the private sector in this space began only about 5 years ago or so. Before that, really, it was all just stuff being done in universities, funded by the government, and that was generally very unambitious work. And then very, very small number of organizations like My One Sense Research Foundation, working with very small budgets funded only by philanthropy. But starting about 5 years ago, that began to change. Started getting involved as investors, especially as early stage angel investors, seed investors. And a lot of those people also were donors. So they would come to me and they would give us money to the foundation, but they would also be interested in knowing where to invest money in private sector companies. And so our business model at Sense actually transformed. We essentially reinvented ourselves so that our business model now is to essentially work on projects for as long as it takes to get them to an investable stage, and then spin them out as startup companies. We could never have done that 10 years ago because the investors were not there. And then you mentioned the FDA, so this is a very important thing that's happened. The regulatory regime around this is changing rapidly now. In particular, the FDA have now essentially gravitated to a a sufficiently detailed and concrete understanding of what aging is that you can do a clinical trial with aging as the clinical endpoint. And in fact, there's a trial about to start up called the TAME trial, which is a test of a very old and well-known drug called metformin. Essentially, the way that they've done this is by creating an extremely complicated but nevertheless sensible combinatorial definition of the endpoint, so that there are a bunch of different um, health conditions of late life that are already perfectly good clinical endpoints individually, and they found a neat and ingenious way to combine them into a single clinical endpoint. And so now we have basically, something the FDA does actually recognize that is not really called aging, but it is aging in orbit name.
Right. Interesting.
Yeah.
So, given that that's the new environment at a regulatory level, how soon do you think we're going to see drugs emerge on the market for the mass market to afford?
Well, because this is a combinatorial problem and we have to invent, as I said, a cocktail of different things, we can definitely expect that they won't all come along at the same time. So things that are in clinical trials right now, among the low-hanging fruit there. I mentioned earlier that, I think before you came on, that there are stem cell therapies being tested in the clinic now for Parkinson's disease, and there are other stem cell therapies coming along. There are also clinical trials going on for what are called senolytics, which are drugs that kill off cells that have got into this kind of zombie state where they're actively toxic, and they secrete nasty stuff. These cells called senescent cells. As I say, that's also a clinical trial stage at this point. And once something gets through all the way through phase 3 clinical trial, it gets approved. So fairly soon. Now, of course, in terms of affordability, you have to look at the manner in which the bills will be paid. So in the US, of course, healthcare tends to be private, and people pay for these things with health insurance, and we have to make sure that that's possible. But that's another thing that is also changing rapidly right now. The World Health Organization has a catalogue called the ICD, the International Catalogue of Disease, which is used by physicians around the world to identify and to justify prescribing this or that treatment for this or that condition. And aging is now in that thing as well, as of a year or two ago, in a very correct way. It's used as a kind of what's called an extension code, so a qualifier of other codes. And again, it's going to change the incentive structure a great deal in terms of affordability of this or that drug, and of course in terms of the incentives to develop these drugs from the point of view of big pharma. So yeah, everything's moving in the right direction.
It's awesome, man. I think, this is great. I mean, I think I'm going to continue to try to promote this. I'm going to start out by going to church this Sunday and trying to promote this at church. Maybe we might get some followers.
Well, yes, absolutely. And I think this is actually, thank you for mentioning that, because this is something that a lot of people don't immediately understand until it's explained to them.
Yeah.
Well, people of faith in general, whether it's Christianity or anything else, are inclined, in the absence of information, to take the immediate kind of knee-jerk reaction that this is kind of playing God, or at least it's against God's plan or whatever. And
Right.
of course, there is an easy answer to that, which is that, hello, this is not about making people live a long time. God can strike you down with a thunderbolt whenever he feels like it, however healthy you are. Right? The purpose of this is to alleviate suffering, because let's face it, aging causes far more suffering than any other phenomenon in today's world. And so, it would be a sin not to work on this.
Yep.
Um,
Yep.
and, that needs to be explained to people of faith quite often. They don't necessarily see it on their own.
Yeah.
A huge thing that we've been following on my program with the scholars that we've interviewed and continue to talk to on a weekly basis is the role of the introduction of manufactured vegetable oils or seed oils, and the linoleic acid, the amount of linoleic acid, which is a polyunsaturated fatty acid that is an essential fatty acid, and the omega 6 particularly is the problematic one that we've looked at. The levels of omega 6 linoleic acid that we're consuming because of these vegetable oil products introduced from artificial industrial processes, mostly, it really didn't take off until, the halfway point of the last century. But they were introduced at first as cottonseed oil as an industrial waste product that they could turn into cattle feed, and then they figured out how to get humans to eat it after the Civil War, but didn't really catch on until Ansel Keys arrived, and he got everybody to stop eating butter and traditional saturated fats and so forth, and move people towards this idea of eating vegetable oils. But what we've seen time and time again is that they seem to be such a key indicator in the rise of things like cancer, of things like diabetes, heart disease, aging related diseases. We look at their effects on creating obesity as an epidemic. Basically, from what I've seen with the literature and the scientists that I've talked to, people like Professor Bruce Hammock of UC Davis, is that, in other words, Cancer, for example, was a indie band that vegetable oils discovered and put it on the top Billboard charting, in terms of sales. It made it a mainstream hit that was a rare disease before. And I wonder if that's a big thing that you guys are going to, like, whatever diseases, whatever medicines you come up with are going to have to mop up some of the damages of this, of the inflammation that's caused by these food products.
Totally. So, of course, there is an enormous impact of diet on the rate of various types of accumulation of damage in the body. And, suboptimal composition of the fats that we eat is a big part of that. I do think it's important not to get that out of proportion, though. Fact is that, the things that mostly drive the rate of accumulation of damage are things that don't have to do with the diet or a lifestyle for that matter. Like, the very worst thing that you are doing for your aging right now is breathing. And I don't mean breathing pollutants, I mean breathing oxygen, because oxygen at the end of the day is really bad for you. It's the source of free radicals that cause enormous amounts of damage. But of course, breathing is rather non-negotiable. So we have to actually think exactly in the way that you just described about mopping up and repairing damage, as opposed to necessarily slowing down the rate at which the damage is created in the first place. Then again, there are ways in which the rate of accumulation of damage. There's one company that I work closely with named Retrotope. I don't have any financial interest in it or anything like that, so full disclosure and all that. They're friends of mine. And they're particularly exciting because they've got a way of manipulating fatty acids, including linoleic acid, so as to reduce the rate at which they get oxidized, which is why they are bad for you in the first place. Why we have to be careful which ones we eat and how much. So there may be ways to make a difference there, but you're quite right that the main thing we want to do is cope with the damage that's already been done and get rid of it.
What are some lifestyle choices, exercises, supplements, drugs that maybe you would feel comfortable disclosing with us that you think are good for us to? I mean, I know we're not asking you to give medical advice or recommendations to yoga or whatever, but what are you doing in your own personal life that you can disclose that that's helping you get ready for the acceleration to blast off?
So you took the words out of my mouth. I am a PhD, not an MD, and therefore, I'm not in a position. It's not really my area of expertise to decide on particular things that people should be doing or taking. But I can talk about myself. Unfortunately, if I talk about myself, that's also not very informative because I'm just a really lucky guy. I'm well built. I have perfect glucose sensitivity, even though my actual insulin levels are almost undetectable. I've got almost no triglycerides or peroxides in my blood, things like that. So I'm just really lucky. I'm just well built, and as such, I can basically eat and drink what I like, and nothing happens. And and so I take the view that if it ain't broke, don't fix it, and so I do not actually take any supplements or anything like that. Though of course I do pay close attention to my metabolism, and if and when, as and when I get to the point where it does make sense for me to adjust things, I shall certainly do so.
So you don't recommend like a breathing exercise or anything like that to kind of slow the aging down until we can get these medicines to boost off and mop up everything?
No. Basically, breathing is non-negotiable, like I said.
And breathing is the elephant in the room, you think?
Oh, definitely, definitely. I mean, oxygen is the way that oxygen is used in the body. In other words, being combined with nutrients as a way of extracting energy from those nutrients. That thing called, aerobic respiration. It's only evolved once in the history of life, two or 3 billion years ago, and it's an extraordinarily hairy, complicated, elaborate mechanism, and it's just inherently risky. That's where free radicals come from, because individual electrons fall out of proteins and get attached to oxygen in the wrong way, and all hell breaks loose thereafter. And that's just not going to not happen.
I see.
We don't want to take too much of your time because we know you're actually doing stuff in the world. So with that, I want to thank you for doing this for us, man, because this has been a long time in the making, and I really appreciate it. I'm going to do my part to get the word out. And, I'm sure David is already on task. So, we really appreciate this.
Well, the pleasure is entirely mine. I'm very grateful to you for having me on the show.
Thank you so much.
Bye-bye then.
Okay. Ciao.